Okay, so our game was.
Hold on.
I didn't hear that.
Okay. Our physics game was monkey cliff diving, and that's Corey. I'm Katie.
This is Emily.
So before we start playing the game, I just want to explain the 3 different types of monkeys that were in the game. The first one was the hat monkey, which has trouble with wind, and you'll notice when she starts to play it, is it whichever direction the wind is going, that's the way that monkey travels. The second monkey is the red monkey, otherwise known as the skinny monkey, and that monkey has trouble with gravity. So when that one comes on the screen, it'll be red. And the third monkey is the average monkey, which has trouble with his wife, and he just falls straight down.
You have the clicker.
I don't know how to click that link. Oh. So Corey's gonna demonstrate how this game is played.
Sorry, everybody. I'm not a gamer. This game is also brought to you by Team.
So off to the left there, you can see the 3 different monkeys chugging up and down. Those are the ones that I explained. Ready? Yeah. Okay. So the whole goal of this game is you have to try and click on the monkey to make it dive at the appropriate time. So you have to kind of time it right so that they hit the waves instead of the rock, and also
Like that.
you have to take into consideration the wind. And up at the top left, I don't know if you can see it or not by the score, there's a little flag, and that just kind of indicates which way the wind is going. So again, that applies to the hat monkey. And also, as you can see, you have 5 different errors to make before you move on.
The red one's the hardest because it falls the slowest.
Right.
So you have to time it right. She's doing good.
I'm trying, so, nope, there you go.
So yeah, and the quicker that you click the monkey to dive, the more points you'll get. And also, if you don't click the monkey in time, it'll just jump off the cliff. So you have to try and time all of them right as they go.
So our first qualitative observation was watching the monkeys actually fall from the cliff. And we know that in free fall, the only force acting on the monkey is gravity. So if 2 monkeys are standing on the same vertical height, or they're jumping off the same part of the cliff, they should hit the ground at the same time. But in this game, we know that that does not happen, because when you watch them fall, they all fall at different times and they take longer. And since we know that Newton's second law states that force is equal to mass times acceleration, the acceleration should be equal to the force over mass, which is the mass times gravity over mass. So we know that acceleration is equal to gravity. But our game does not follow that whatsoever, as you can see.
Our second qualitative observation is that it appears that the monkeys are all falling with a constant velocity. And we know that Newton's first law states that if something is moving at a constant velocity, it will only do so if the net force is 0. So we know that this isn't true in the game because F net equals ma, and there is acceleration because there's always going to be acceleration due to gravity in free fall. So this cannot be true.
Okay, for the quantitative observation, the first thing that we did was we looked up how tall the average monkey was in real life, and it came out to be, I'm going to write these numbers on the board. The average height of the monkey was 0.51 meters. So then what we did from there is we measured how tall the monkey was in the actual game, and that came out to be 1 centimeter, which is 0.01 meters. And then what we did is we just simply put those over a ratio to each other to figure out the scalar, and it ended up being 51 to 1. So what that tells us is that everything that happens in the game, you multiply it by 51, and that's how you get your real life values. So the first thing we did was measure the height of the cliff. So what you can see, that picture up above, we actually chose the height where the monkey was at the top, because it was easier for us to use that. So we measured on the screen, and it came out to be 0.082 meters. So then we multiplied that by 51 and got 4.2 meters for our distance. And we ended up using that as our final position, which also makes it negative, because we chose at the top of the cliff, our initial position was 0, and it's falling downwards, so that would be negative. So then, from there, we ran 3 different time trials, and we averaged the time, and what we did was we calculated the monkey at the top. We used the red monkey, which is the skinny monkey, that falls the slowest, because again, it was easiest for us. But we used the monkey at the top, and we timed it until it hit the rocks at the bottom. So what we did was the 3 time trials, we averaged it, and our average time came out to be 3.2 seconds. So that was our T. And then lastly, we used the kinematic equation of the final position equals the initial position plus 1/2 acceleration t squared plus the initial velocity times time. And what we know from that, the reason that we use this is because we know the initial position is 0, our initial velocity is 0, and that's because our monkey's at rest. So then also what we calculated was the distance from the top to the bottom of the cliff, so we know that y final is 4.2, and we also know that the time is 3.2 as we calculated from our 3 time trials. So using that, you can see off to the right up here, it's rearranged. Once we canceled everything out, it ended up coming to acceleration equals 2 times the final position over time squared. And what that gave us was an acceleration of negative 0.82 meters per second squared. So obviously that's not very close to our actual value of negative 9.8 meters per second squared.
Okay, so we found a percent error, and the accepted value for the acceleration due to gravity, according to Dr. Iggy and a lot of textbooks, is negative 9.8 meters per second squared. So to find the percent error, we just did the accepted minus the measured over the accepted times 100, and we got a 91.6% error, which is not even close to the actual value.
So in conclusion, based on our large percent error, it's safe to say that the makers of this game ignored the basic concepts of physics, and but we decided that the makers did this probably on purpose, because if each monkey were to fall at negative 9.8 meters per second squared, there would be no anticipation on whether or not the monkey was going to hit the wave or the rock, because it would just fall so fast that you could pretty much time it, and the game would be super easy. And none of the monkeys, it wouldn't make any, like, if there was a hat monkey and a skinny monkey, it wouldn't make any difference, so it really wouldn't be that much fun. So basically what we learned is that mistakes are fun. Physics mistakes makes the world fun. So that's all we have. Here are our references. Does anybody have any questions? Does anybody have any questions that aren't Dr. Iggy or anybody else?
All right. In your opinion, does the monkey hit the rocks with the same force as the rock hits the monkey?
Well, in this game probably not, because they're so full of mistakes, but in theory, it should.
Were any monkeys harmed during this?
I'm not very good at this
Especially when
game.
I played.
Yeah.
The first 5 monkeys that I hit, they didn't all die. So.
Me and Katie weren't too good, that's why we had Corey demonstrate.
Man, I'm not very good, so you can imagine how many were harmed.
Yes. Did it confuse you guys that the skinny monkey had the most trouble with gravity?
Yes.
It was so backwards. It was just, yeah.
Alright, let's thank our speakers again.
You're so long.
Fill out the movie. You do it as you go. It's the
It's like